You don't have to throw away your scripts and playbooks to use network orchestration. With Itential, you can keep your automation code and add rich workflow orchestration to it. Visit itential.com to find out more. That's itential.com.
Take a network break. I'm Drew Conry Murray.
I'm Jonna Johnson.
Grab a virtual donut and settle in for today's show. Jonna, we've got some cool stuff today. What are we covering?
Well, we're going to be talking about some new advances in quantum computing, computer companies plunging into networking, and some financial results, and a bunch more, as always.
And just a quick reminder, if you like Network Break, we've got a whole bunch of other podcasts over at packetpushers.net, including Day 2 DevOps, Packet Protector, that's our security show, Heavy Strategy, that's a show with Jonna where they get into IT strategy, Network Automation Nerds, and N is for Networking, which covers essential networking topics for people coming into the industry, or if you just want a refresher, you can find them all at packetpushers.net. And Jonna, let's start with Red Alerts.
Sure. So this week we saw another 1,250 CVEs, with 348 of them being critical, that is with a CVSS of 9.5 or better, and 62 with a straight 10 out of 10. However, of all of these, we really want to just highlight Google's Chrome, thanks to CVE 2025-0998, which is an out-of-bounds memory access bug that allows a remote attacker to execute arbitrary code inside a sandbox via a crafted HTML page. Fully fixed in updates after 133.0.6943.98. So please update your browsers, because this will hit anyone running Google Chrome.
Yep, and we've got a link to that in the show notes. And John, every time you say 10 out of 10, I just imagine the folks at NIST with like those judging cards from figure skating, holding it like,
I know, that's what I always think of. What was it? Komenichi. What was her first name?
Nadia Komenichi, yeah.
Nadia Komenichi, the first to get a 10 out of 10. And now here we are.
We're showing our age.
We are.
All right, diving right into the news, Microsoft has announced a quantum computing chip called Majorana 1, which the company says will help create a pathway to practical quantum computing within years rather than decades. There's a lot to unpack, and Jonna, you're, I think, much more well-versed in quantum than I am, so we're going to be going back and forth here. But first, Microsoft says it has summoned new quantum particles called Majoranas into existence. According to Microsoft, Majoranas, quote, don't exist in nature and can only be coaxed into existence with magnetic fields and superconductors. And you've got some background here.
Yeah, and I would just say, Drew, Microsoft has gone a little overboard, as we'll point out, with some of the verbiage around this. But basically, Majoranas are fermions that are their own antiparticles. And you're going, what is a fermion? Well, a fermion, basically, particles can be sort of loosely grouped into bosons and fermions. Fermions follow Fermi-Dirac physics, which include things like you can't be in the same place at the same time, more or less, again, loosely speaking. Some very familiar particles like electrons are fermions. However, electrons are not Majoranas. Majoranas are simply a form of fermion that was mathematically hypothesized almost a century ago by a guy named, an Italian physicist, I might point out, being half Italian myself, Ettore Majorana, back in 1938. So the big deal here is that they were hypothesized but not created until now.
Okay, so I think I'm going to try to do my bogus Italian Majorana every time I say that now going through the rest of the show. So Microsoft also says it's found a way to work with a new state of matter called a topological state, which apparently has advantages over other approaches to quantum computing.
Yeah, and I'll just jump in and say topological qubits are one of about 7 categories of qubits, depending on how you want to slice and dice things. These include superconducting qubits, quantum dot qubit, trapped ion qubits, photonic qubits, defect-based qubits, nuclear magnetic resonance qubits, and of course, topological qubits. Each of them have pros and cons, and if you want to get really deep into that, come drop me a line, because this is a space we cover very deeply. The big con until now for topological qubits is nobody's been ever able to make them. Now, there have been people trying and working very hard at various places. For example, the University of Minnesota, Carnegie Mellon, Pitt, UCSB, among others. The big news here really is that Microsoft actually took an idea that's been around for almost 100 years and made it a reality, which is a very big deal. And the next thing is that among all the different types of qubits, Microsoft has made one of the more promising ones into reality.
Okay. Yeah, and I guess the issue is that qubits are delicate. They can be disturbed by surrounding environments and, of course, by measurement, and you need measurement if you're going to do computation. So Microsoft is saying that topological qubits are more stable and controllable.
Yeah, and actually, not just Microsoft, but quite a lot of other folks have said, hypothetically, were we able to build them? They would be. All of this in subjunctive tense until Microsoft made its announcement. Now everything is in present tense. So it's not, I just want to clarify, this is not just Microsoft's claim. All the other scientists who've been researching it are researching it precisely because they're more stable and controllable.
Yeah, I'm sure Microsoft is standing on the shoulders of physicists and material scientists who have been working on this, in labs and obscurity.
Absolutely. But
Yeah.
for listeners, I just want to be clear that this, we're all so used to vendor makes claim X, discount 90% of it. And I'm saying the vendor is making a claim that has been bolstered by all the people actually doing the science who have absolutely no relationship to Microsoft. So you can kind of probably believe it.
So we're not talking science fiction here.
Exactly. Although it sounds very science fictional.
It does. And just moving on, the chip needs other infrastructure to function, of course. Microsoft says the infrastructure includes a dilution refrigerator, quote, that keeps the qubits at temperatures much colder than outer space, end quote. So I think IBM also has actually rolled out a quantum computer that can, they say, process up to 100 qubits. But it's essentially like a giant piece of equipment that has to be kept very cold, so very energy intensive. This is not something you're going to have in your house anytime soon.
And actually one of the big things about, for example, photonic qubits is they don't need to be refrigerated. So that's why when I say there's all sorts of pros and cons, it's like, does it need intense refrigeration? Can you fit one in your hip pocket? How fuzzy is it? How likely is it to be disturbed? These are all things you have to, it's an engineering trade-off between them.
Of course.
But yeah.
Microsoft says it can currently place 8 qubits on the current chip. The long-term goal is to scale to 1 million qubits on a chip. A Microsoft blog claims that, quote, all the world's current computers operating together can't do what a 1 million qubit quantum computer will be able to do.
That is actually correct. This is something we've done a lot of research on. There are types of what you call quantum problems, quantum ready problems. So there are certain problems that simply cannot be solved by classical computers. In fairness, however, there are also problems that quantum computers can't solve. So, while this is absolutely an advance, this is one of those examples of, oh, wow. If you just read that naively, it would sound like this is taking the laptop on your desk and making it 800 billion times more powerful, and it's not quite. It's solving different types of problems than your laptop could ever solve.
Sure. Well, we obviously know one of the use cases is cracking classical encryption, but there are other things like drug design, material science design.
There are also, one of my favorite ones is something like policy hardening, because you can actually, with a quantum computer, you can basically take a problem that is so multifaceted it can't even be formed on a classical computer, like, gee, what diplomatic steps could I take that would not result in war with country X? And to figure that out, you immediately realize that's not possible to figure out because it depends on so many variables, almost an infinite number of variables that can be in infinite ranges. That's the kind of thing quantum computers are actually very good at.
So we're going to see quantum computers playing each other in the game diplomacy?
No, games less interesting, more real diplomacy. Game, anything that has rules and can be boiled down to sort of binary kinds of decisions, classical computers with a little AI assist will do just fine at. It's when you get into the real world where it's like, if you think about it, like predicting the weather. Accurately predicting the weather is something that quantum computers could do, not just with probabilities and whatnot, but like, don't walk under that tree because it's about to be struck by lightning.
Interesting. So Microsoft says it's been working on this project for close to 2 decades. They have a couple of papers out, one in the journal Nature. We have links to those papers if you want to dig into more of the gnarly details. And Johnny, you got a couple more comments.
Yeah, I just want to weigh into the fact that, this is a great advance for Microsoft. Yay, Microsoft. But for listeners, I'd like to take a step back. This is contextually a huge deal because it showcases the degree of effort that not only is underway at present, but has been underway for decades to enable quantum computing. And the big deal about quantum computing is that we were able to show back in the last century that it was theoretically possible. Not possible, but theoretically possible. So this is something that we knew for most of my entire lifetime that this would actually be game-changing when we got around to being able to do it. What is new and important here is that not only has Microsoft been able to figure out one way to do it? Google's been able to figure out another way to do it. There's those 7 kinds of qubits. There are people actively working on all of those. And earlier this year, I got into a debate with an Amazon quantum computing specialist about the timeframes for quantum computing. And he was saying, I know, here at Amazon, we still think they're a decade or more out. And I said, well, you're wrong. You're going to be seeing cryptographically relevant quantum computers, CROCs, within 5 years. And here is why. It's because of the degree of investment across countries, across companies, across research firms, and most importantly, across technical methods. There's somebody placing a bet on every single kind of qubit out there, and one of those bets is going to come through. Even if 99.9% of all the bets fail, that 0.01 is going to come through. So it's kind of like we're at that state where you put the popcorn in the pan, you've turned up the oil. The first pop happened, there was a long pause, maybe another pop, and now with Google last week and Microsoft this week, we're at that stage where all the kernels are popping at once, and we're about 30 seconds from a bag of piping hot, ready-to-eat popcorn.
Speaking of popcorn, reading Microsoft's materials, I feel like I'm reading, in like Marvel movies when they have to do the technobabble plot dump, like I've just synthesized a new form of quantum energy that will allow us to time travel in the multiverse. That's what this feels like. And I'm not saying it's nonsense or made up. It's just got that vibe because it is so groundbreaking, futuristic.
It really is. And I guess my hackles get raised only because I think people tend to take it sounds like something out of a science fiction movie and then slap on the assumption that it can't be real. And my only point is it is. Maybe, Microsoft is bet on the right horse here. Maybe Google did. Maybe IBM did. Who knows? But somebody will, and soon.
Awesome. Well, plenty of links on this story in the show notes that accompany this podcast if you want to dive in for yourself. But we'll move on. But sticking with quantum, Johnny, you've got another story.
Yeah, right. And now from the world of legacy quantum computing.
Oh, no.
Boy, that was really fun. That was really fun to say. D-Wave quantum computers are now available for high-performance data centers. Those who have been following remember that D-Wave is one of the commercial companies that sells quantum computers, and it is now selling its quantum annealing computers for on-premises installations with the, hang on, I can pronounce this, the Forschungszentrum Jülich High-Performance Computing Center as their first publicly announced customer. The D-Wave Advantage systems have more than 5,000 qubits and 15-way connectivity, but they are annealing systems rather than general-purpose quantum computers, meaning they're useful only for a subset of quantum advantage problems. Loosely, think of them as the BlackBerry of the smartphone. When BlackBerry first came out, you couldn't surf the web, you couldn't do anything, but you could send email. So it's kind of like that. By the way, the offering that they are making for HPCs includes shipping, installation, calibration, and ongoing maintenance, and I guess they have an ongoing warranty with that. I don't know. I've got, I don't know if it's getting serviced by quantum mechanics. But in any event, if you wish to buy one, you can do so now for your HPC center. And we've got a link in the show notes.
I'm tempted to just stop the recording now after the quantum mechanics joke, because I don't know that we can get any better. No, but we will carry on. Moving on to a new topic. Computing companies are getting into networking. Apple's announced the C1. This is a custom 5G modem that's going to debut in the iPhone 16e handset. Apple designed the C1 itself, reducing its reliance on Qualcomm. Apple acquired Intel's modem business unit 6 years ago, according to Tom's Hardware. So this is one of the first fruits of that acquisition. Apple says the C1 is the most efficient modem ever on an iPhone, but it does come with trade-offs. You won't get support for Wi-Fi 7 or other advanced radio features that boost performance but are also power hungry. So Apple's sacrificing some advanced capabilities for better efficiency.
Better efficiency and control of the supply chain, I would add.
Yeah.
There's that. And following right along with the computing companies getting into networking theme, Meta's Project Waterworth would build the world's largest subsea data network. So there are tons and tons and tons of undersea cables. You can look at the growing and changing maps from telegeography. Pretty much every quarter things are new. But Meta announced last week that Project Waterworth, which is aimed at building an undersea cable network connecting the 5 major continents that would comprise 50,000 kilometers of cabling and be the world's longest subsea cable project.
Wow.
They claim they're going to deploy the highest capacity technology available, including 24-pair cables to connect technology and population centers in Brazil, India, Southern Africa, and other key regions to the U.S. They note that 95% of intercontinental internet traffic traverses subsea cables and intends to deploy what they call first-of-its-kind routing to maximize use of the cable laid in deep water, as well as improved cable burial methods in high-risk areas so that we don't get those news stories about fishing boats or other
Air quote on
boats,
fishing boats.
right, damaging the cables. It's always interesting to me to see when computing companies say they're jumping into networking, there's always a high probability of unanticipated failure because networking is generally harder than computing companies think it is. But both of these sound like they make very good sense, and we'll keep an eye on them going forward.
And I do think Meta has a track record of actually deploying its own subsea cables. So, often tech companies will make very bold globe-spanning pronouncements, but I do think, they have a track record here, and it probably is in their interest to get more fiber out there. So yeah, we'll keep an eye on this, but it does seem like, I don't know, will they get to 50,000 kilometers? I don't know, but it does seem like this is not just smoke and mirrors. A quick break to hear a message from our sponsor, iTential.
In my Python work, I have found that there is lots of power, but lots of detail. The deeper I go into the code, the more challenging it gets to keep the network up to date as I intend in an automated way, and as a result, I tend to write a script that does a specific thing predictably, and that's it. Now, if I am honest, I am not as disciplined as I should be about error handling. I start off with a script that works fine most of the time, but if it fails, I do not always have the code for that, and I say this to my shame. And the problem is compounded if I were to try to integrate a bunch of other systems together beyond just the network infrastructure, such as updating the source of truth or acting on telemetry or reacting to network discovery, interacting with ServiceNow, etc. This is where iTential makes fantastic sense to me. I want a platform that helps me handle those interactions, that makes it easier to handle exceptions, that can execute a rollback if a change didn't go well, that can talk to any API I need it to without it being a big deal. In other words, iTential's tools give me a platform that I can build an orchestrated workflow system on top of, no matter what my company's tool stack looks like. And I can do that all while integrating scripts and playbooks that I've already written. I don't want to have to throw all that work away just to use iTential, and I do not have to. iTential just makes what I've created work better and plug into my company's IT infrastructure. To find out more about iTential's products and how they help you build a network orchestration platform that integrates with your business, visit iTential.com. That's iTential.com, and tell them Packet Pusher sent you.
In other news, the SASE vendor Aryaka is announcing a new capability called AI Observe. The goal is to provide advanced threat detection in its SASE portfolio. Aryaka has partnered with a company called SecureTech, which provides the AI models that Aryaka is using, as well as human analysts. Aryaka is using the data it collects from customers to run inside these models, and the goal is to streamline incident response. That means customers will get to go to a new dashboard to review incidents surfaced up by Aryaka and SecureTech. They can get details on the incident, including packet captures if relevant, and access playbooks to formulate a response. AI Observe will be an add-on to existing Aryaka services and will be priced by the number of users and sites. Link in the show notes if you want to read more about it.
Yes, and that is yet another case of SASE vendors adding AI, always a trend. Moving right along and kind of coming back to the networking theme, T-Mobile is finally shutting down 2G. Yes, you heard that right, 2G. U.S. carrier T-Mobile notified users and announced on its website that it started shutting down its 2G mobile network, which has roots going back to 1996. It actually announced shutting down 2G in April of 2024, but held off until now. It has already shut down its 3G network, as well as the 3G CDMA and LTE networks it inherited from Sprint. But you may ask, why is it taking such a long time to shut down 2G? Well, that's because there were an awful lot of IoT devices that were still using 2G. It will offer free replacements for the 12 of you who are still using 2G handsets, but not for the 2G devices, which are smart meters and other IoT nodes. And links are in the show notes.
Yeah, I was wondering, I was just assuming there's got to be some legacy gear out there running on 2G. It's the kind of thing that you rarely touch because it's just sort of, like systems have accreciated around it, and taking it out is hard. So I guess folks have had plenty of warning, but the time is
still,
here.
Yeah, if you have not actually put in place your plans to replace your IoT networks, you might want to do that.
Yeah.
And moving on, Azure is shifting away from x86 to ARM. Lifter Insights has released a report showing that a third of all infrastructure instances deployed in Microsoft's Azure environment in Q4 2024 were actually built around Microsoft's own ARM-based Cobalt chipsets. This represents a significant twofold displacement. First, it's part of Microsoft's ongoing shift towards ARM and away from x86 architectures. And second, it displaces Ampere Computing as Azure's primary ARM-based system supplier. So in other words, not only is Microsoft moving away from x86 to ARM, it's also moving away from third-party ARM providers to itself.
Yeah, not great news, particularly for Intel or for AMD. And it's, we also just talked earlier about Apple with its self-designed modem chip. It seems like if you are a big enough company and you can find a reason to do this, designing your own chip has dividends.
Yep. And, again, it's just another sign of the times, I guess.
Yeah. All right, we'll wrap up with some financial news. We'll start with Cisco. Cisco recently reported its Q2 2025 earnings. For the quarter, Cisco earned revenues of $14 billion, up 9% year over year, with net income of $2.4 billion. That's down 8% versus this time last year. The company said AI infrastructure orders totaled over $350 million. Breaking out by product category, networking brought in $6.8 billion for the quarter, down 3%. Security was $2.1 billion, up 117%. Collaboration was just under $1 billion in revenue, up 1%, and observability was $277 million, up 47%. I'll note that there's a line in Cisco's financial release saying that if you exclude Splunk sales from those results, then security was only up 4% and observability was only up 3%. So those kind of numbers are showing why Cisco was so interested in bringing Splunk into the portfolio.
Yeah, that really read like, listen, guys, that was a good decision. Come on, give us credit for it.
Right. I did look at the transcript of the earnings call that the executives have with Wall Street financial analysts, and reading between the lines a little bit, it seems like the analysts are a little worried that Cisco isn't getting the same size bump from the investments in AI infrastructure that other companies are getting. For its part, Cisco says they do anticipate seeing more of that bump as more enterprises deploy AI infrastructure in-house, which is reading to me like that Cisco doesn't have as great a presence in the hyperscalers and others doing the mass AI build-outs compared to somebody like Arista, but is expecting some of that bump as enterprises start to build out their own AI capabilities, and we'll see if that proves true.
And Drew, I don't want to hit you with a curveball, but the thing that leapt out to me about this announcement was that revenue is up, but income is down, which says to me that costs are up. Do you have any thoughts as to why the costs would be up?
I do not, actually. I know that tariffs were also an issue in the earnings call. I don't know. There's just sort of uncertainty about the tariffs, what's going to happen. I don't know if Cisco has, done some cost maneuvering. They said they were anticipating this and trying to not necessarily have to raise prices for customers, but they will if they need to. But I don't know if that has anything to do with it. There also could be tax things or costs just went up for whatever reason.
Well, and costs are usually people, but yes,
Right.
it's good to focus on materials as well, which may have been rising in anticipation of the tariffs. So that's a good thought right there.
Yeah.
Okay, just curious.
Yeah. Moving on, Arista Networks also reported Q4 and full year 2024 financial results. For the quarter, revenues were $1.9 billion, up 25% year over year, with net income of $801 million. For the full year, Arista had revenues of $7 billion, up 19.5% over last year, and a record for the company. Net income was $2.9 billion. What Arista calls its cloud and AI titans accounted for 48% of its annual revenue. And within that category, Microsoft is responsible for 20% and Meta 15% of that revenue. So Arista is essentially bankrolling lots of money out of these two companies. Enterprise and financials accounted for 35% of revenue, with providers rounding out at 17%. Looking ahead, Arista expect to book revenues of $1.5 billion directly from AI-related sales in 2025. So definitely that AI infrastructure tide is raising Arista's boat. And our last for today, Palo Alto Networks recently reported results for its second quarter of fiscal 2025. Revenues were $2.3 billion, up 14% year over year. Net income was $300 million. Palo Alto Networks says SASE customers increased by 20%. Looking at appliances, security appliances, it anticipates somewhere between 0 and 5% growth for the appliance market. So it's leaning heavily into the growth potential of SASE, as well as the sale of virtual firewalls in customer cloud deployments. And in talking about the modest appliance growth versus cloud in the earnings call, the CEO said, quote, "The good news is the cloud volume is going up faster than the data center volume is declining." So Palo Alto signaling appliance sales are going to be flat, but virtual and cloud are growing.
Yeah, I mean, that basically just says our transition to cloud is working, because obviously if that weren't the case, it wouldn't be working.
Right.
It would be very disturbing.
Yes. And one interesting note that I gleaned from the earnings call transcript, Palo Alto Networks said that it's internally deployed a co-pilot, and by this I presume they mean like an AI support tool for its global customer support business. The co-pilot's trained on network security issues, and Palo Alto Networks says they've seen the co-pilot used in about 85% of customer support cases related to network security, and saw a 50% reduction in time to resolve these cases. They say this means they can increase the number of customer support cases they can handle without increasing headcount. Now, of course, they're saying this on a call with financial analysts, so it's going to be a rosy story. But, Jonna, I'm just out there sort of like trying to gauge my own level of AI skepticism, and this seems like a data point in favor of targeted use cases for AI tools.
Yeah, and in fact, root cause analysis is in fact one of those use cases that absolutely shrieks for AI application, because essentially it has all the pieces you need. Hallucinations don't quite matter, because essentially when you're trying to do root cause analysis, you want all the possible ideas, you want them sorted down to the most likely ideas, and then you want a human looking over that to root out anything that might be just completely implausible or goofy. And that's great, because that's what AI does super well, super fast, and super effectively, and super thoroughly in a way that humans just don't. So I'm not at all surprised. I think they're reporting honestly. I would expect that if somebody hired me to go in and look at it, I'd probably get very similar results, because that's what we're seeing in enterprises as well. That kind of incredible improvement for very targeted root cause analysis. So, hey, there you go.
Right. So maybe that's also a point in your own gauge of AI skepticism, listeners. Link in the show notes if you want to see the results for yourself. That does wrap up the news and this episode. Jonna, if folks want to reach out to you or get in touch with you or see what you're up to, where should they go?
I'm on LinkedIn, and you can also hit me up at Nemertes. That's NEMERTES.com. There's a contact us, and I will happily respond.
I'll also note that Nemertes puts out a good weekly newsletter, sometimes written by you, Jonna. If you're just looking to sort of keep an eye on, sort of the big trends going on in the tech space, it's a good newsletter, worth your time and worth your subscription.
Oh, well, I thank you for the plug.
Yeah, sure. Yes. I'm Drew Conry-Murray. I'm on Blue Sky at DrewCM, and I'm blogging at packetpushers.net. Thanks to our sponsor, iTentional, and thanks to you for listening. You can always reach out with comments, corrections, or kudos at packetpushers.net/FU. And don't forget, we've also got merch, a dozen podcasts you can subscribe to, our industry blog, 2 weekly newsletters, a community Slack group, a YouTube channel, an IRC group, and more. You can find everything at packetpushers.net. It's all free, no gating, no login, so come and check it out. And as always, thanks for listening.